Okay, we're on to the Algebra 1 STAAR Study Guide, Lesson 5.2. The last one, writing and graphing exponential functions. So this is just going to be dealing with more about how to read and understand the tables and graphs of exponential functions. So we're just going to jump down and start here. Population of fish in a pond is growing at an exponential rate of 25% per year. I'm going to put a plus sign above growing because I know it's going to be adding at an exponential rate of 25% per year. The initial population was 425 fish. Choose the correct exponential function to model the situation. All right, so first things first, we know B is not the answer because this initial starting point is not in the right place. 425 should be out here. So then the question becomes, how do we represent a growth of 25%? Is it 1.25? Is it 0.75? Or is it 25? So we have to understand conceptually what's happening here. When we say 25%, the first thing we need to understand is that does not mean times 25, because that would be 2,500%. So times 25 or a whole number of 25 doesn't make any sense as the answer. It's never going to be that. So the question is it 1.25 or 0.75? So you should notice that both of these represent a change from 1, either up 0.25 or down 2.5. And so what's happening is that the growth of 25% is represented as a plus 0.25 and leading us to 1.25. And so if it was decay, it would be 0.75 because then we would have gone down 0.25 from 1. So that's how we know this is answer choice A is the correct answer. You're going to do the same concept on number 2, except the other way around. So I'm going to let you do that one on your own. You identify the initial value and the amount of growth. And remember, the growth or decay is always from 1. So you need to find how far has it changed from 1 to get the number inside the parentheses. Number 3, an exponential function contains the 3 points 0, 1, 1, 3, and 2, 7. Use a graphing calculator to find the values of A and B in the equation. Okay, so I'm going to put a link in the video description, but there is a Desmos graph that works with this type of problem. It's called exponential regression. When you do regression, what you're doing is you're finding the value of the line that crosses through certain points. You're finding the line that fits those points the best. So if I do this and I put these 3 points in, 0, 1, start here, 0, 1, 1, 3, and 2, 7. I put those points into this table, and what Desmos is going to do is it's going to spit out a bunch of numbers. And the numbers that are the most important are these parameters because they are the A and B. And if you notice in the problem, they give you this A, B, X. They want you to find the values of A and B. And so that's what Desmos gives us. And this is what a graphing calculator like a TI or a Casio calculator would do. But Desmos does it in, I think, a little bit more straightforward way. So we need to look at the A value, which is 1.167. And so, well, that's interesting because it doesn't have the same answer. Let me just zoom in here and make sure that maybe I didn't make a mistake somewhere. So that's very strange. We're going to select 1.04, and then we are going to select 2.45 for our B. 2.65. So I'm not exactly sure what the issue is. It must have to do with the calculator they use somehow has a different way of finding regression. But I would choose the answers that are the closest to the ones you get on Desmos. So I'm not really sure what's up with that, but that's okay. Then we get to what graph. And this is just a matter of you finding these points from this table on this graph and making sure which graph matches those points. So I'll let you do that one on your own. Probably the key point here is going to be 1 and 1.04 and whether or not the graph has that point on the graph. And then you can find the others as well. So just match up the points on the graph with the points from this table right here, and you'll be fine.